Stratospheric aerosol injection is one of the most widely discussed methods of solar geoengineering, and it's easy to see why. The idea is to release massive amounts of aerosols into the stratosphere, where they'll reflect a small percentage of sunlight back into space and thereby cool the planet. Sounds simple, right? But as we'll see, the devil is in the details. For one thing, we're not entirely sure how effective this approach would be or how long it would last. For another thing, we're talking about making massive changes to the Earth's atmosphere, and that raises all sorts of questions about unintended consequences. David Keith, the director of the Climate Systems Engineering Initiative at the University of Chicago, discusses solar geoengineering.
Solar geoengineering, particularly stratospheric aerosol injection, offers a potential method to temporarily reduce global temperatures by reflecting sunlight away from Earth. However, it comes with significant risks, including potential impacts on weather patterns, ozone depletion, and uneven distribution of effects. While it could help mitigate some effects of climate change, it is not a substitute for reducing greenhouse gas emissions. Rigorous research and careful consideration of ethical and governance issues are essential before any deployment.
Dr. Renee Hannon, an environmental policy expert at Columbia University's Climate School and a geologist with 40 years' experience in the energy sector at Arctic locations, provides more information.
Solar geoengineering poses significant risks and ethical concerns. The potential for unintended consequences, such as changes in weather patterns and impacts on agriculture, cannot be ignored. Moreover, the governance of such technologies is complex and could lead to geopolitical tensions. Instead of relying on geoengineering, we should focus on reducing greenhouse gas emissions and investing in sustainable solutions.
One of the reasons solar geoengineering is so hotly debated is that it's still largely untested. We're talking about making massive changes to the Earth's climate system, and yet we're still in the early stages of understanding the potential consequences of those changes. And that's why it's so important to have a nuanced discussion about the pros and cons of solar geoengineering, rather than simply jumping in with both feet. After all, we've seen time and time again how well-intentioned solutions to environmental problems can end up having disastrous unintended consequences. Here are some governance considerations that may take years to effectively resolve. International cooperation. Effective governance requires international collaboration, as the impacts of solar geoengineering would be global. Regulatory bodies. Creating independent regulatory bodies to oversee research, testing, and potential deployment of geoengineering technologies is vital. Transparency and oversight. Ensuring transparency in research and decision-making processes is crucial. Public engagement. Involving the public in discussions about solar geoengineering is essential. Open dialogues, public consultations, and educational initiatives can help raise awareness and build consensus on the ethical and social implications. One of the biggest concerns about stratospheric aerosol injection is the potential impact on global precipitation patterns. We're talking about making changes to the atmosphere that could have far-reaching effects on weather patterns and that could be disastrous for certain regions of the world. And yet, despite these concerns, there are still many scientists who believe that stratospheric aerosol injection could be a key tool in the fight against climate change. Another method of solar geoengineering is Marine Cloud Brightening, or MCB. The idea here is to release massive amounts of sea salt into the air, where it will form clouds that reflect sunlight and cool the planet. This approach raises all sorts of questions about unintended consequences, from the potential impact on marine ecosystems to the risk of acid rain. Some of the research objectives for MCB are feasibility assessment. Scientists are evaluating the viability of MCB by studying how clouds respond to aerosols, or particles, in the atmosphere. This involves understanding the physical processes that govern cloud formation and behavior. Risk evaluation. Research is focused on identifying potential risks and unintended consequences of MCB, such as changes in weather patterns and impacts on regional climates. Modeling and simulation. Advanced computer models and simulations are used to predict the effects of MCB on a global scale. These models help researchers understand how MCB might influence temperature, precipitation, and other climate variables. One of the most contentious issues surrounding solar geoengineering is the question of ethics. Who gets to decide whether or not to deploy these technologies, and how are they going to be held accountable? We're talking about making decisions that could have far-reaching consequences for entire regions of the world, and yet we're still in the early stages of understanding the potential risks and benefits. There have been several high-profile instances of solar geoengineering being proposed or tested with dramatic consequences. One of the most famous examples is the so-called ocean fertilization experiment, where a private company dumped massive amounts of iron into the ocean in an attempt to stimulate the growth of phytoplankton, which absorb carbon dioxide as they grow. The primary goal was to test whether adding nutrients like iron can stimulate phytoplankton blooms and enhance carbon sequestration. Nutrients were added in the form of powdered iron sulfate or other compounds. These were dispersed over large areas of the ocean to promote phytoplankton growth. Tests have been conducted in various parts of the world, including the Arabian Sea, the Southern Ocean, and off the coasts of Australia and Hawaii. While some experiments have shown initial increases in phytoplankton, the long-term effectiveness and environmental impact remain uncertain. Concerns include potential negative effects on marine ecosystems, such as creating oxygen-depleted dead zones and altering food webs. Due to these concerns, international bodies like the United Nations and the London Convention have adopted regulations to restrict ocean fertilization activities. Let's take a look at a real-world scenario to illustrate the stakes involved in solar geoengineering. Imagine you're a resident of a small island nation in the Pacific, where rising sea levels are already threatening your way of life. Your government is considering a proposal to deploy a solar geoengineering technology that could potentially save your island from disappearing beneath the waves. But as you start to dig deeper, you realize that the technology is still largely untested, and that there are serious concerns about its potential impact on global weather patterns. As we explore this scenario, it becomes clear that the stakes involved in solar geoengineering are incredibly high. We're not just talking about the potential risks and benefits of a particular technology, we're talking about the very future of our planet. And yet, despite the gravity of these issues, there's still a surprising lack of public awareness and engagement about solar geoengineering. The reactions from different stakeholders have been telling. Environmentalists are often strongly opposed to solar geoengineering, citing concerns about unintended consequences and the potential for catastrophic mistakes. Governments, on the other hand, are often more cautious, weighing the potential benefits of solar geoengineering against the potential risks. And scientists are often caught in the middle, trying to navigate the complex ethical and political implications of these technologies. As we analyze the reactions from different stakeholders, it becomes clear that public opinion on solar geoengineering is far from clear-cut. We're talking about a complex interplay of competing interests and values, with no easy answers in sight. And yet, despite the challenges, it's clear that we need to have a more nuanced and informed discussion about solar geoengineering. So what does it all add up to? Is solar geoengineering a necessary tool in the fight against climate change, or are we playing with fire? The answer, as we've seen throughout this video, is far from clear-cut. There are strong arguments on both sides, and ultimately the decision will depend on a complex interplay of scientific, political, and ethical considerations. Thanks for watching, and we'd love to hear your thoughts on solar geoengineering in the comments. If you want to learn more about climate solutions, be sure to check out our other videos on carbon capture and storage.